Okay, so now let's go ahead and take a look at an example where we have function pointers with essentially function parameters, right? So again, what you have on the screen is the same old example modified a little bit. Here now you'll notice that each of these functions take an input parameter of an integer, call it a here, b here, and we are just essentially printing the values of a and b. What has changed now is this keyword right here. So earlier, recall, we didn't have this, which meant the function pointer was pointing to code that is not taking any function parameters. In this case, we are saying it takes an int. That's all, right? And everything else remains same in terms of assigning the function pointer to the address, assigning the function pointer to the address of the function. Also notice here that I'm using the ampersand just to suggest that using it or not using it has the same effect, right? In some places you will see people use it, in some places you will see people not using it. That's fine. Recall, what you're not supposed to do is put parenthesis here and then put some number inside of that or pass the argument. That you're not supposed to do. Just the function name or ampersand and the function name, that's good enough. All right. And then another difference is that here, instead of now just func ptr open close parenthesis, we are passing the number 10 and 20 here. And based on what the outcome of this is, I would like to explain or hammer home few points. All right. So let's go ahead and compile it, gcc main.c, and then execute it. Oh, okay, execute it. What you'll notice is, in this case, you have a equals to 10. So this was assigned the value of 10 because we passed 10 here. Next line, we have b equals to 20 because b was assigned the value of 20. So then that is function pointers with input parameters. And uh, one slight variation that I would like to suggest now, which is also what most of the source code out there that is written in C would have when we are talking about function pointers, is essentially this, that you would not see this being put here. Rather, there is something called typedef, which is redefinition of a data type, or so not or but redefinition of a data type. And so idea is that instead of writing this long statement again and again repeatedly, what people would do is kind of do a type def of void, void, let's say, star func ptr, and say int, and that's it. So now what happens is, once you see, and this is what you see in most source code out there in practical world. So once you have a function pointer like this type def, what you have done is you have defined a type, a data type, right? And so you can now just do func ptr, say pf, and this time around pf is a variable which is pointing to a function of this signature, right? So this is absolutely correct in terms of, okay, let me erase this. So this is absolutely, correct in terms of usage. It's the right syntax, but it's, not as much readable. And if you want to use same kind of function pointer in multiple places in your code, for whatever reason, and we'll come to the reasons when we discuss the examples. So just, take it on faith right now that this is heavily used. But if you want to use function pointers of a similar signature, then writing this code again and again is very cumbersome, non-readable, all of that. So C provides us with a way to create or define our own type, a data type, so to speak, and we define a function pointer type of type, right? Data type. And so my claim is, next time on, you cannot do func ptr equals to function one, for example, and we'll see quickly execute this also. So you cannot do this. This is okay. What's happening? Okay. Let me just find my eraser. Nice. Okay. My claim is this you can no longer do once you have done this. What you need to do is define a variable of the function pointer type and then assign that variable, right? Let's just quickly try that out, and let's move this out of the way. Let's make this you know outside of our function and then say type def, and this is enough. So at this point what we have done is said, hey, func ptr is essentially the type that we have defined happens to be a function pointer type. And so we're going to copy this, and let me go ahead and say pf, right? And then let me go ahead and do pf here, pf here. And now what I can do is I can also say, I can either reassign pf here, which is also fine. Let me go ahead and do that. So let me quickly go ahead, compile, run the code, same output, same behavior. If I attempt, let's undo this. If I attempt to, let's say, okay, if I attempt to run this code, which was our original code, except we typed def and moved this out, you'll notice that it doesn't compile, right? And this is what I was pointing to, or this is what I was suggesting, that once you have type def the definition of a function pointer, which is this, not definition, but declaration, uh, then essentially you can no longer use function ptr as the variable because it's a type now. And so what you have to do is define a variable of that function pointer type and then call that variable. So here then I'll go ahead and again have func ptr. Let me just do it, and then let's call it qf, right? And then let me assign qf the value of, and then qf here again. Let me compile, compiles fine, and then execute, same result. Again, your takeaway or the things that I want you to remember is once we have type def the function pointer declaration here, this name of the function pointer becomes a new type, right? And that new type is function pointer type. So next time on, when we are using it, we create a variable of this type, right? We can no longer use this name. That's the idea. That's the only thing you need to remember. And you will see this over and over again and again in the Linux source code. You'll see this in FreeRTOS source code and so on and so forth, right? There are reasons to using this. The idea being, this is so much straightforward, right? Than me having the same line put here but called different thing, then same line put here and with this name changed. Let me also kind of, before you get confused, leave you with what I'm meaning when I type that. So let's get rid of this. So let's say I didn't have the type def and I wanted to execute these two functions through the function pointer with different names, then I would need to do, let's say, something like so, right? And then I would need to also, so this my claim is, okay, let me put a semicolon here. This my claim is would have the same effect, but notice I have to do this ugly syntax twice. And like the type defs help us get rid of something like this, right? All right, with this, we're pretty much done with the function pointers.